and welcome to my series Learn Radiology with Dr. Anil Joshi. It has got different sets of videos. Some are in detail covering radiophysics, some are in a short form. Now this lecture we have made simplified and the extensively same topic is covered in the larger lecture which is available in the same series over the YouTube or on my website. Now today's lecture is going to be on the components of X-ray machine. Now this is going to be covered in extremely brief. At first, disclosure and disclaimers. The slide material and much of the work has come from our departmental routine teaching schedule. It is coming on since many days. We are using it for every year for teaching purposes. Some material has come from the net which is free of royalty and without any financial liabilities. We acknowledge with thanks those from whom we have received this material. Now here we start with the lecture, that is components of the X-ray machine, or the what things are there in an X-ray machine. Now we'll see one by one. Now primary component of X-ray machine are, there is X-ray tube, then there is power supply, then X-ray tube is positioned within the tube. So X-ray tube, that is a glass tube within the outer metallic housing along with some component of the power supply. All these details are covered in some other lectures. Now X-ray tube we'll see grossly. It is composed of a cathode and anode situated with evacuated glass envelope or a tube. Why evacuated? If there is a gas, it will oxidize the heated part, or the fast moving electron will collide against it and reduce their speed. So it has to be evacuated. Then electron emitted from cathode to target the anode are produced. They produce the X-rays. So there has to be production of electron, there has to be acceleration of them, then there has to be a deceleration, that they have to hit with something and they have to get converted into the X-ray or a pocket of energy, that is photon. Now let us go in more detail what it has got. X-ray tube has got cathode. It consists of a filament and a focusing cup. Why focusing cup? Because filament can eliminate electrons in multiple directions. They need to be streamlined. So you have to have a negatively charged focusing cup which will streamline them. Now it has to have filament. Now why filament? Because filament produces electronic cloud by a principle called thermionic emission. Then coil of tungsten makes the filament. It is 2 mm in diameter and 1 centimeter or so in length. Many tube has got 2 filament. Because we need sharp images, we use a different filament, and if there is a heavy exposures like lumbar spine, angiographies, we have to use a larger focus. So smaller focus basically works for a sharper image but at low MA, and a larger focus works for the angiographies, large heavy radiographs where more exposure is required. Then it is mounted on a stiff of wires. The filament is mounted on mounted on 2 stiff wires. Then it has to be heated. Heating is for thermionic emission which causes a electronic cloud around it. So to get more and more electron, the tube has to be supplied with electricity which will heat up and produce free electrons. Now these emitted electrons at a rate proportional to the temperature of filament. So more the temperature, more will be the electron, or larger will be electronic cloud. Now negatively charged concave reflector made of molybdenum, then parabolic shape it has got. We are talking of a focusing tube. Why focusing tube? The electron should not move in all directions here and there. They have to get streamlined at a perfect target. So we have got a focusing cup which is negatively charged. The electrons are also negatively charged, so they will get away from each other and see that they are streamlined in the center in a narrow beam. Now this beam is directed at a small rectangular area on the anode, that is called a focal spot. Now electron move in this direction. Why? Electrons are negatively charged and cathode is positively charged. So negative will get attracted to positive and the electron will start moving out. In that again the potential difference is applied so that they will get rapidly accelerated. So all these electrons will move towards a focal spot. Now they are also repelled by the negatively charged cathode towards anode. Then attracted to the positively charged anode, they will go and hit it. Now we have discussed this all in detail in a production of X-ray. There is another video for that. Now here we are showing you it is a fixed anode. There is a filament which is elaborating. Now see the role of focal cap. The focus cup keeps them in a streamline. It doesn't allow them to move here and there. It is negatively charged. Electrons are also negatively charged. And because the angle of target, the angle of the anode, they will get straight down to the area we need. Now, if you see anode detail, it has got 2 components. One thing is a copper block and second is the tungsten where there is a focus spot. Now, X-ray tube, again to recapitulate, let us see it again. It's evacuated to prevent collision of the fast moving electrons with gas molecule and significant significantly reduces their speed. So because it is evacuated, there is no such thing occurring in the tube. It prevents oxidation or burnout of the filament. That is a two rule why it is evacuated, why there is no air inside. Now this is a stationary anode. It is consisting of tungsten as a target embedded in a copper stain. Tungsten we have discussed high melting point. Copper we have discussed is high dissipation of heat. It is excellent combination. Then it converts the kinetic energy of colliding electrons into the X-ray photons. How? Because of the rapid deceleration. Because of the cut down of the speed, rapid deceleration, the fast moving electron will get converted into the photon. So that we call as an X-ray. Both are same, synonymous. Then why tungsten? Ideal target material. It is ideal target material because it has got high atomic number 75, high melting point. So in spite of heating, it will not melt. Now it has got thermal conductivity in a very high way and really dissipate the heat. So whatever heat get generated at one spot, it will be immediately passed to the adjacent side. And low vapor pressure at a working temperature that is maintained by the vacuum. So these are the things which we are repeatedly telling and reviving. Now stationary anode has got copper stain. Why copper stain? Because 99% of the electrons when they get converted into photon, that is X-ray, 99% production is of heat and hardly 1% are the X-rays. Now this heat needs to be dissipated. Copper is an excellent conductor. That's why it is used to dissipate the heat in a fast way. Additionally, there is insulating oil between the glass envelope and the housing. Housing is what we have seen, a metallic outside, what we see a tube. In between that and a glass, there is a oil. Now this oil, what it does is it carries heat further. So it is another thing by which the heat is dissipated and the things are kept at a working condition. This is stationary anode designs, how it works. Now focus spot is an area on the target to which the focusing cup directs the electrons or where the X-rays are produced. Now sharpness of the radiographic image is inversely proportional area of focal spot, and heat generated per unit target area increases as the area of focal spot decreases. So these things needs to be kept in mind. Now further focal spot, there is a line focus principle. What is it? To take advantage of a small focus spot with distributing electrons over a larger area of the target is placed at an angle to which the electron beam hits or bombards. That is what we have seen. When we have seen an anode, there was a wedge. There was a slanting. So that shape is given so that line focus principle can be achieved. This angle is called as angle of truncation, that is 20 degrees. Some machines it has got 15 also. Both are correct. 15 is also correct, 20 is also correct. Effective focal spot is smaller than the actual focal spot. Now let us see another. It is the rotating anode. We have seen stationary anode, now it is rotating anode. See the difference. It has got a rotor, it has got a stator, then it has got a glass tube that is common to both, then it has got a focus spot that is common to both, focusing cup is common to both, filament again common, and electronic beam is common. Now here what is happening is a focal spot is changing because the rotor is rotating anode. Every time a different surface comes in contact, a different area which produces the X-rays. That's why the tube is more efficient, heat dissipation is better. Here again the target is of tungsten and it is bevel disc. Bevel disc is because of the what we have seen is the effective X-ray production. It rotates when the tube is operating at a speed of 3600 rpm rotations per minute. Then it strikes successively area of target. So every time the different area of target is hit by the electron. Why? Because the anode is moving. Now if there is widening of the focal spot by an amount corresponding to the circumference of the bevel disc. Now distribution of the heat over this extended area further helps to make it more efficient. That can result into, you can take heavy exposures, you can give exposure for longer time, and secondly you can take exposure at successive rate like you need for the angiographies. Now see the tubes are designed. You can see the focal spot is now called as a focal tract because it is a moving. Then so it can accept tube current up to 100 to 500 mA. So it can work at a higher mA, that is 10 to 50 times that of the stationary anode tube. Then 3000 to 3600 revolutions per minute is the speed in different machines, and it cannot be used for intraoral dental X-ray machines. Why? because of its larger size. You cannot handle it easily. It has to be mounted to the large X-ray stand and machine. But it can be, it is used in a tomographic and cephalometric units at certain centers or at some machines. But most of the machines do not have rotating anode. Most of dental machines do not have rotating anode machine. But they are always used. Which one? Rotating anode. Are always used in medical computed tomography X-ray machines required for high resolution of output. Now this is the tube, what we had discussed. Now power supply is by a generator. Now you can see here primary, secondary, different type of generators used to give different type of power to the different units. These all are discussed in detail in some other lecture. We have got another lecture in this same series, in short, in condensed form, so also in an extensive form in our another lecture series. Both are available, condensed as well as larger or in detail. Now what power supply does? It heats the cathode filament to generate electron. Electronic cloud is generated by them, and to establish a high voltage potential between the anode and cathode to accelerate. So once there is a difference between anode and cathode, more and more, there will be more and more acceleration, and more acceleration will result into more and more X-ray production or better KVs. Large capacities X-ray will be produced from them. Now the transformer is a filament transformer, and the another is meant for the tube and exposures. Now transformer is a totally different topic, and it is also covered in the same series somewhere else. Here it is just to give you a brief idea about the components of the X-ray machine. Now tube current is here we are shown primary, secondary. Why the tube current is given? Tube current is given to heat a filament and also for the exposure purpose. The flow of electron through the tube or filament tube, anode, and then again back to filament. For that you have got a transformer which is used either as a step up or step down transformer. Then there are two coils, primary as well as secondary coils for these transformers, and it is the role and its principle is discussed somewhere else. Now filament circuit basic principle is to heat it. So it reduces the voltage to about 10 volts. So only 10 volts are given because you have to just heat it. There is no need for further higher capacity electricity. Then regulated by a filament current control. Then regulates the filament temperature and thus the number of electron emitted at 10 mA. Then this is not the same as that of the current in the filament circuit. So these two are different. The transformer design has got different for both, and the circuits are different. Now tube voltage is regulated by auto transformer. This is another type of transformer, step up transformer, step down transformer, and third is auto transformer. These three are discussed in three different lectures. High voltage is required between the anode and cathode, gives these electrons sufficient energy to generate X-rays. Now peak KVP selector adjusts the auto transformer. The auto transformer used in a KV selector button. So this is another thing we should know. What a KVs you are changing on the machine, below that is the auto transformer. Now it boosts peak voltage of the incoming line 100 to 120 volts up to 60,000 to 1 lakh volt. That is 60 to 100 kV. In some machines up to 130 kV. So this is a very high increase. Now energy 60 to 100 kV sufficient to generate X-rays of high penetrating capacity. Now polarity of AC current alternates. So does the polarity of the X-ray tube at the same frequency. Now for that, so X-ray is produced when only filament is negative and target is positive. Now again this diode or rectification we are going to see in some other lecture. In the other half there is no production of X-rays. If it is half-wave rectification, you can get alternate half which gives the X-rays, and in continuous if you want, then you will have to go for a full wave rectification. Now rectifiers will tell you how this is done. This half of the cycle is called as inverse voltage or reverse bias. That also we are going to see in some different lecture. Limit of X-ray production This what will it will do? It will give X-rays only when there is a curve, which is, you can say, upward curves. So only 50% of the cycle will be used to get the X-rays, and therefore it will limit the production of X-ray to only half the cycles. So it has to be a full wave rectification. Now this principle we are going to see in the different lectures. So 60 pulses of the X-rays are generated each second, and each is having a duration of 1/120 seconds. This is just to know the rectification or self-rectification, or called as half wave rectification. This is in a smaller unit, but larger unit has got full wave rectification. Now see, here you can see, look at the wave. Now I'll explain you. This is the upstroke, this is the down, this is a routine, a normal waveform. Now if you want to have, this is a negative side. So if you want to have a continuous X-ray production, the ray has to move in the same direction. So if this negative will not work. So in that, here what we have done is, we have in output converted this negative into a positive, this side, and this will give you a continuous X-ray production, that is called as full wave. In half wave, what will happen is, this cycle will be suppressed. So if this cycle is suppressed, it is half wave. Then if it is converted into the opposite side, then it is full wave. So you can have either half wave or full wave rectification. Now some dental X-ray manufacturers produce machines that replace the conventional half wave rectifier power supply with a full wave rectification. That is what we have discussed, because that is more efficient, gives more X-rays and more continuous X-rays. This will result in essentially constant potential between the anode and cathode. There will not be a gap between. I mean, energy of the X-ray being produced comparatively higher than operated at the same voltage. So full wave rectification machines will give you a better X-rays and a continuous X-ray flow. Now timer, very easy to understand. How long you want the X-ray to be on? X-rays are produced not continuously at a certain time. A timer is built into the high voltage circuit to control the duration of the X-ray exposure. This you can control. You can have higher or lower depending on the part you want to radiograph. Subjecting the filament to continuous heating at a normal operating current shortens its life. Now try to understand this. To minimize filament damage, so it will keep machine on only when required. When not required, machine will not be kept on. That is, X-ray will not be produced. It will have better control over the situation, and the timer will save both. It will save electrical energy also and wastage of X-ray also, and it will give a correctly required exposure. Now tube rating, one has to understand. Tube rating is what can be the maximum exposure you can achieve from the tube, or whether tube can be used successively for the multiple exposures. Now this will depend on the multiple factors. X-ray tube produce heat at a target while operating. This heat need to be dissipated. Now measured heat units where HU, kVp, MA and second matters. So more the kVp, more is the heating, more is the MA, and more is the second, the heat production will be more. Now dental diagnostic tube is approximately 20 kVA. They are small tubes, they need less exposure, and you have got limitations on that. The heat is removed from the target by conducting the copper anode and then the surrounding oil of the tube housing by convection to the atmosphere. So what happens? The heat is produced at a target, then it is transmitted to the anode. Anode has got copper block in it, then it passes it to the glass housing. In glass housing there is a oil that further dissipates it, and then ultimately it goes to the atmosphere. Now the tube rating describes the longest exposure time the tube can be energized for a range of voltage and current with safety, that is without risk of damage to the target and overheating. Now whenever you need a higher exposure, the intraoral tube has got limitations, so always go for the extraoral, which has got higher heat dissipation. With this we are coming to end of a short lecture in which we have given you a brief idea about the components of the X-ray machine. Here we have described them in very brief, very shortly. For more comprehensive, you can refer to my another YouTube series where you will get detailed discussion over this topic as well as in other topic. I thank you for giving me your valuable time. Please visit our website for comprehensive and detailed lecture over this topic and also on many other topics. With this, I thank you. I wish you a good luck. Take care and be more and more useful to the patient by gaining knowledge. For that, you have to know the designing of X-ray machines also, so that you can maximum extract benefit out of it. Thank you. Take care. Goodbye.